Welcome back to this video. So we continue solving questions from tutorial sheet 1, which is basically on algebra, okay, but applied to the field of medicine, of course. Okay, so we have so far solved question 1, okay, all these questions. Question 2, we solved all these questions. Question 3, we also solved question 4, question 5. Okay, so in this video, we'll be looking at question 6 and 7. So question 6 is basically on the drug doses, okay, as well as question 7. So that's what we'll focus on in this lesson. Okay, so we start from question 6a. Okay, so they're saying a physician, okay, orders 75 milligrams of phenylethylamine. Okay, so this is probably some medication. Okay, so however, only 100 milligram tablets are available. Okay, how many tablets should the patient be given? Okay, so this physician, okay, wants to order 75 milligrams. Okay, however, only the 100 milligram tablets, okay, are available. So the question now is that how many tablets should this patient be given? Okay, so here we're going to use ratios. Okay, we're going to use ratios. So we're going to say one tablet, okay, one tablet contains 100 milligrams. Okay, so now what about if I want 75 milligrams? How many tablets am I going to have here? So we are going to represent those number of tablets as X. Okay, and then from here, we're just going to simply cross multiply. So if I cross multiply, what I get is 100x is equals to, and then here to be 1 multiplied by 75, which will give me 75. So I divide this by 100. Even this one, I divide by 100. So it means my x will just be 75 over what? Over 100. Okay, so we can represent this as a decimal. So it means my x is just simply 0.75. Okay, so for me to have the dose, okay, of 75 milligrams, then I need 0.7 tablets. Okay, so the patient should be given 0.7 tablet. So if you notice, those tablets are like this. Okay, so if one of these is 100 milligrams, okay, the one that should have 75 milligrams, how should it look like? So you've noticed that on the tablet, those two demarcations like this. Okay, so if this is 100, okay, it simply means this here is 25, this here is 25, this here is 25, this is 25. So if I only want 75, it means I have to cut some part of this tablet, like this one. So I have to cut this part here so we can erase it. So we can say, let's erase this part here like that. So the tablet that should be given should be like this. Just remove a small part there, which was the 25. Okay, so how many tablets should be given? 0.75 tablets, which is something that looks like this. Okay, so we are done with A. We go to B. Okay, so B, we are basically using the same concept. Okay, so B, they're saying this physician now orders 25 gram of a drug. So 25 gram of a drug. Okay, so in stock, only a vial of the drug with a dose of strength 10 grams per 15 milliliters is available. Okay, so how many milliliters of this drug should be given to the patient if they order 25 gram? So we are still using the ratios. So here I'm going to say if I have 10 gram of this drug, then I need 15 milliliters. What about if I have 25 grams? Okay, how many milliliters am I going to need there? So I'm going to cross multiply. So what I get is 10x is equals to 25 multiplied by 15. Okay, so it means my x here will just be 25 multiplied by 15 divided by 10. So it means X is equals to, okay? So my X will be equals to, if I punch this on my calculator, I get 37.5 milliliters, okay? So if I have a drug, okay, of that mass, 25 grams, then I should give the patient, okay, 37.5 milliliters of that, of a solution to go with this drug. Right, so here we are done. Okay, so remember here we found 0.75 tablets, and I showed you a picture. Here, how many milliliters? We found it, it's 7.5 milliliters. Okay, so now let's look at the third one. Okay, still using ratios and proportions. Okay, so the third one, they're saying this physician now orders 3 grams of an injectable drug solution for a patient. However, only a vial of a solution with a dose strength of 325 milligrams, per 2 milliliters is available at the hospital pharmacy. What volume of the on-hand solution should be administered to this patient? Okay, so we did the same like we did here. So they are saying if they have 325 milligrams, okay, then they need 2 milliliters. So now, how many milliliters do they need if they have 3 grams? So you notice that here we have grams, here we have milliliters. So our first thing is to convert this 3 grams to milligrams. Okay, so how do we do that? Okay, we learned this in chemistry, I taught you guys. So we said 1 gram is equivalent to 1,000 milligram. Okay, 1 gram is equivalent to 1,000 milligram. So meaning if I have 3 grams, how many milligrams am I going to have? 3,000. Okay, so that's what we're going to write here. So we're going to write, what about if I have 300 milligrams? What volume do I need? Okay, so we cross multiply, it will be 325x is equals to 2 multiplied by 3,000. So meaning x will just be equals to 2 multiplied by 3,000. That will give me 6,000 divided by 325. Okay, so this, when we punch into the calculator, we get approximately, okay, we get approximately 18.46 milliliters. Okay, so it means this patient, okay, if there's 3 grams of a medicine, should be given approximately 18.46 milliliters of the what? Of the solution. Okay, so we're done with question 6. Let's look at question 7. Okay, so question 7, okay, question 7, they're saying an IV bag contains 1,000 milliliters of dextrose in saline solution with a drop factor of 20 drops per milliliter. Okay, and has been set to run for 6 hours. Okay, find the rate flow of this solution in drops per minute. Okay, so if we're finding the rate of this flow in drops per minute, then it means that our flow rate is given by the formula total drops, okay, divided by the total time that you have. Okay, this will be our flow rate. So what we are going to do here is first organize what we've been given. Okay, so we have been given that the drop factor, or just write DF, the drop factor is 20 drops per milliliter. Okay, 20 drops per milliliter, and has been set to run for 6 hours. So that is our total time, 6 hours. Okay, so 6 hours, if we change it to minute, it will be 60 times 6, which will just give me what? 360 minutes. Okay, so my time in minutes is actually 360. And then the drop factor is 20 drops per minute. Okay, what else have we been given? Okay, we have just been given this. So now, okay, we have also been given the total volume there. Okay, total volume. So total volume is 1,000 milliliters. So now from the drop factor, we are told that the drop factor is 20 drops per milliliter. Okay, 20 drops per milliliter. So if I have 1,000 milliliters, how many drops am I going to have? Okay, so we're going to say total drops is equals to the drop factor 20 multiplied by the total volume that I have, okay, in milliliters, of course. So 1000 like that. So this is going to give me the total drops that I have. So 20 multiplied by the 1000, I get 20,000 drops. Okay, so these are the total drops that I have. Okay, so now I can find my flow rate because I have the total time and the total drops. So my flow rate here will just be equals to the total drops, it is 20,000 drops, divided by the total time in minutes. Since here they said find the flow rate of this solution per minute. So this will be 360 minutes. And then these are drops. Okay, so we can punch this into our calculators. Okay, so I'm getting approximately 55.6 drops per minute. Okay, so this is the flow rate. So that's how we solve question A. Okay, so we found the answer here to be 55.6 drops per minute. All right, so now let's look at B. Okay, so B, we are basically doing the same thing, but now we are finding the drop factor and this B. Okay, so let's read the question. So we are saying an heavy bag contains 1,000 milliliters. So total volume 1,000 milliliters, okay, of a solution, and its infusion into a patient's blood stream was started at 9 a.m. Okay, and it ran until 12 p.m. Okay, so from 9 a.m. to 12 p.m., how many hours have passed there? Okay, 3 hours. So you can change these 3 hours to minutes, so that will be 60 multiplied by 3. So I have 180 minutes. Okay, so this is my total time. We can say this is my total time. Total volume is there. Okay, and then here they've given us the flow rate. They're saying with a flow rate, okay, so flow rate equaling 15 drops per minute. Okay, my flow rate is 15 drops per minute. Okay, and then they're saying this was at the start. So at the start, the bag contained 1,000 milliliters there. Okay, so this was at 9 a.m. And then at the end, at 12 p.m. here, they're saying at 12 p.m., the IV bag contained 200 milliliters. Okay, so it means some of the volume has been used. Okay, so volume used is equals to the total volume that we had at the start, which is 1,000, minus the one that has remained after 3 hours has passed and we are at 12 p.m. So that is 200. So it means the volume used here is just 800 what? Milliliters. Okay, so now what are we calculating? They're saying find the drop factor. Okay, so the drop factor, okay, is equals to the total number of drops divided by, okay, total number of drops divided by the volume used. Okay, so now how do we find the total number of drops? Remember, we have the flow rate here. So from the flow rate here, we can see that we can calculate, we can make total number of drops the subject of a formula. Right? So total drops is equals to flow rate multiplied by total time. Okay, total time we have, and then the flow rate we also have. So we can calculate the total drops. So total drops will be equals to the flow rate 15 multiplied by the total time 180. So this will give me what? Okay, so this gives me 200, 700 drops. So these are the total drops. Okay, so now to calculate the drop factor, okay, to calculate the drop factor, we are going to say total drops 2700 divided by the volume used, which is what? 800 milliliters. So this gives me approximately, okay, this gives me approximately 3.3. In fact, this is not approximate, but it's exact. So let me write it somewhere here. Okay, so the drop factor, the DF, will just be equals to, when I divide this, it's giving me 3.375 drops per what? Per milliliter. Okay, so this is the drop factor. So we've answered the first part there. Okay, we've answered the first part. Okay, so let's solve the last part there, part 2. Okay, so let's just keep the drop factor that we found because we are going to use it. Okay, so now let me rewrite some things here. So we said from this question here, okay, the flow rate, we found it was 15 drops per minute. In fact, we were given. And then the drop factor, we calculated it. Okay, the drop factor, we calculated it as 3.375 drops per milliliter. Okay, so now this last part here, they're saying determine at what time the entire bag will be completely drained. Okay, so remember that at 9 a.m., okay, we had 1,000 milliliters. Okay, and then we moved to 12 p.m. At 12 p.m., they said only 200 remained. Okay, so it means we had used from this 1,000, we had used 800, right? And then here we only have 200 milliliters remained. So now they want us to find a time, okay, a time X at which there will be 0 milliliters here. Okay, so we want to find this time here. So what are we going to do? What we're going to do is this, okay? We are going to say, since we have the drop rate, okay, and the amount that is remaining at this 12 until a certain time where this is 0, okay, the amount remaining is 200 milliliters. So we can say, let's calculate the total number of drops, okay, total drops that will come out from this 200 milliliters, okay? So now remember, the drop factor is 3.375 drops per milliliter. Okay, so if I have 3.375 drops in a millimeter, how many drops am I going to have in 200 milliliters? Okay, so I'm just going to multiply the drop factor multiplied by the volume that is remaining. Okay, so this one is going to give me the total number of drops. So if you punch this, I'm getting 675 drops. Okay, so for this 200 milliliters to finish, there has to be 675 what? Drops. Okay, so these are total drops. And then the flow rate, we already have it. So from the formula of the flow rate, we said flow rate was equals to the total drops divided by the total time, right? So we're interested in finding this time. So how long does it take from here to there? Okay, so this is the total time that we are finding. And remember, this flow rate is in minutes. So the time that we're going to find here will be in minutes. And then once we find that time, we can add it to 12 p.m. Okay, so let's make the total time the subject. So it becomes total time is equals to total drops over the flow rate. So the total drops we've found is 675, okay, from this 200 milliliters. And then the flow rate we're given is 15. So when I divide these guys, okay, I get 45 minutes. Okay, so for this 200 milliliters to deplete, okay, or to finish, it has to take 45 minutes. So if this is 12 p.m., okay, and then it takes 45 minutes to finish, at what time will that volume finish? Okay, so the volume will finish at 12 p.m. plus the 45 minutes. Okay, so the 45 minutes, we can write it in this form. We can write 0.45. So we add this, okay, it's going to give us the time there. So if I add it, I just get 12.45 p.m. So at 12:45 p.m., okay, it means the volume would be finished completely. Okay, and that is it for this tutorial sheet. Okay, so we've actually solved all the questions in this tutorial sheet. All right, so thank you so much for watching. Thank you so much for watching this video. If you like it, we actually have solutions to the full tutorial sheet where we're getting these videos. Okay, so if you go on our website, this is our website, just search discrete learning.com. You'll be able to reach the website here. Okay, so when you come on the website here, you can go down here. This is our home page. So you can go to the course mathematics. So when you open math, you're going to find two folders. Okay, so this is for Apex. So you go in general mathematics for you from Unidas or any other university. So when you go to general mathematics, you're going to find four folders. One is for lessons and tutorials. Here we have handwritten notes, clearly explained. You can use them. Here we have the tutorial sheet solutions. There we have past quiz, test, and exam papers. Okay, so in the lessons and tutorials, what you find there is basically videos explaining all the concepts that you're going to learn. Okay? All right, so I was saying you can see that from the look of things, these the topics are arranged in order in which you're going to learn them. Okay, so set theory, there are videos there, and also some notes for you guys. Okay, all the topics, all the way up to uh, all the way up to linear regression and analysis there. Okay, so any topics that you want, the videos we have them here. Okay, so that is the folder for lessons and tutorials. And then we also have the handwritten notes. Okay, you can go there and then you check out our handwritten notes. Uh, Again, arranged according to topics. Okay, and tutorial sheet and assignments. This is what I actually want to show you. Okay, so there are different universities here. So you go to your university. Okay, so that tutorial sheet was for Unilas. So I'll go to Unilas. Okay, and then I'll find first and second semester. So depending on the semester you're taking, let me go first semester. And then here you find lecture notes for Unidas, okay? And then written solutions for the tutorial sheets, and then here video solutions. So you're interested in the video, you go in the video, and then you find two intakes here, okay? There's the other one, the January intake that passed, okay? Their tutorial sheets are here. So if you open, you see that we have videos from tutorial sheet 1 all the way up to tutorial sheet 8, explaining each and every question. So you can use these videos here to learn. Okay, so whatever concept that you are given, you can come here and learn using this tutorial sheet. But for you guys for July intake, okay, uh, the new tutorial sheet that they gave you, tutorial sheet 1, we are done making videos of it. Okay, so you can see question 1 here, question 2, question 3, question 4, question 5, question 6. So you can access videos for the full tutorial sheet here on our website, and you can learn at your own time, at your own pace, anywhere. Okay, you can use it. I also have to mention that we have a mobile app in case you don't want to use our website. Okay, so it's very good to use the mobile app because on the mobile app, you can even download the videos and then watch offline. So for example, you go to school with Wi-Fi, you can download the videos on the mobile app and then you can watch offline, okay, on the mobile app. So if you would like to install the mobile app, please send me your email address, okay? So the mobile app is only for those who have Android phones. So you can send me your email address and then I'll add you, okay? And then you'll be able to install the mobile app and then use it on your phone. All right, so thank you so much. And continue studying.